hyphenated, I was gone for a day.
It's not as bad as it looks.
Yeah. Yeah, we're gonna take a look at those problems and see how you dealt with them. No, I was gone yesterday because cancer has finally won.
What?
On Monday after school, we got to put it up. Yeah. It just went.
I'm so sorry.
That's how it is. So, yeah, so that's why last week was really disjoint.
I'm really sorry.
Yeah,
That's terrible.
Yeah, it's one thing when they get old, but it's no fun when dogs get cancer. Because they can't talk to you, they can't tell you, or anything. So that's why I was gone yesterday. And earlier in the week was, and it's not that everything's just fine now by any stretch, but we had to put our dog down Monday right after school because he had cancer, and it got real bad real fast all of a sudden, and it was hard to see, and they can't talk to you, and they're tough. Dogs don't show pain very easily, but all of a sudden it was there, so it just, in his bladder, where the two ureters come in from the kidney, and then the urethra leaves the bladder. It's, in a dog, it's about the size of a quarter or a 50-cent piece. It's a really small little triangle openings, and you had a bladder the size of the end of your pinky finger growing in there. So it closed it off, so urine couldn't pass, and that's it becomes extremely painful. So, yeah, so that's what this week started out like. Started out with over 25 years of having black dogs in the house, and then they're not there. So, yeah, so it's been kind of tough. It's no fun putting down dogs because they don't understand, but you hope they do. And dogs are pretty cool, you know. Take your sister or your little brother and lock them in the trunk of the car for 2 hours. And then lock a dog in the trunk of the car for 2 hours and open it up and see which one's happiest.
The dog.
Dog, of course.
You go to jail if you do that to your kids.
They're always happy when you get home, no matter when you get home. That's the way dogs are. Dogs are pretty cool. Really? I've never had a dog mad at me for coming home late.
Well, like if you go on a vacation, they could give you the cold shoulder.
Yeah, they can. But as soon as you get home, it's all over. It's all forgiven. Forgive and forget. Dogs are pretty fun. So, onward, forward. Distance formula. So what was the first ordered pair that I sent home, or sent in my Google Classroom?
12, 7, and 12, -10.
12 and -10. Okay, so if you picture that on a graph, you can turn that into a straight line, right? Yes? So it's like 12 over and 10 down, 12 over and 7 up. So we want to just know how far it is from here to here. So you can just count it on the graph, right? So how many units is it back down to the x-axis? And then all the way down to here? So what's the total distance? 17. So you should come up with a positive 17, right? But if we show the arithmetic, that's what we want to plug in. And the A and the B are the two locations right here and here. So if we did this, 7 subtract a -10 equals, no, it is not -3. Negative is addition. Subtracting a negative is adding. So that's 17, and the absolute value of 17 is 17, so that's how that comes out, 17 units. Did we get something like that?
That's the first one.
Okay. What was the second point? The second set of points that I gave you.
6.5 or -8.
And Negative 8, what was the second one, Kate?
6.5 minus 24.
Negative 24. So that's in a straight line again, isn't it? From negative 8 to negative 24. If you just picture that on a number line, how many units is that? How far do you go from negative 8 to get to negative 24?
32. Oh, no.
So if you're at negative 8 here and you go down to negative 24, so you're like here, you come down. How many units is that? 17?
18.
18?
No,
16. So if you look at it as the absolute value of the difference between these 2 points, we don't have to go left, right. We just have to go up and down. So this is a negative 8 minus 24. I'm sorry, minus a negative 24. So that's the same as adding 24. And you can rewrite that as 24 minus 8, so that's the absolute value of 16, which is 16. What is the answer for the third one that I gave to you? How much is it? 5.5? Okay, so as I walk around and I look at your work, I see a mix of stuff. I see some work looking like this up here. I see some things done without absolute value bars. And I'm gonna have to say, it needs to be done like this with absolute value bars. Because the next thing I'm gonna show you is gonna get more confusing if you do not do it that way. If you set it up so that when you do the subtraction, you always have a planned value that's positive, and then you just eliminate the absolute value bars, that's gonna become more challenging. It's gonna be harder to deal with. So, I'm gonna walk you through a problem, step by step, and I'd like you to copy it into your notes notebook as exact as you can. So here we go.
I wrote it in my notes with the X subscript 2, X subscript 1, that's why I did it that way.
Oh, yeah, X of 2, X of 1.
I did it, that's why I was like, oh, my fault.
Yeah, it's, sometimes you get a prejudication. Hey, you should have 6 different math classes going on, and then have to remember, wait, no, they don't know this yet. That's really a challenge. Okay, so, you guys remember the Pythagorean Theorem? I see here's some, yeah. What was, it was with triangles. What is it used for?
Finding the
Yeah, it's like for finding a length in a triangle. For right triangles, yeah, it only works for right triangles. If it's not a right triangle, you gotta come back in another 3 or 4 years, and then we'll teach you that. So, I want you just to look at this for a minute and watch it, and before you go and copy anything down. If you had a right triangle, and the Pythagorean works like this. Its length is C, and the legs are A and B. It doesn't matter which is which. And we can think of each of these 3 vertices as points on a grid or on a coordinate plane. So if I came over here and I put things on a graph, on a coordinate plane, if I put my triangle in such a way that it would set up like this, this leg would be 3, that would be 4. And if we use the Pythagorean theorem, the hypotenuse is 5, because we have to square 3. We have to take 3 times 3. We have to add that to 4 times 4. And that's equal to c squared. And then we have 9 plus 16. That's 25. And then we have to take the square root of c squared and the square root of 25. And that's where our 5 comes from. But we can look at it a little differently than that. You know, if you think of that leg 3, that's a distance. And the leg 4 is a distance. It's a distance between those vertices. So I'm going to erase this. And I'm going to say that this is a distance. And up here, this is another distance. And this is even a distance. It's just a diagonal distance between 2 points. So what you've done so far is, like, let's say this was 3 miles and this is 4 miles. Well, then that's got to be 5 miles because you use the Pythagorean relationship. But if we don't know how far it is between these 2 points, you need to find out how far that is. And if we don't know how far this is, we need to find out how far it is. Then you can use the Pythagorean. So if I make this a point on a coordinate plane, it's going to have an x value, and it's going to have a y value. And then this point up here, that's also going to have an x value and a y value. Don't copy this down yet, okay? Just take your time and look at it. I'll give you plenty of time to write it. And I might even write it out more neatly and cleanly for you. But these are 2 different points. So we have to delineate them differently. I could say that this one here is point number 1. So we put a subscript of number 1 with it. And here we put a subscript number 1 with that y value. And then over here we're going to do the same thing, but we're going to call it number 2. So this is x sub 1, y sub 1, or point number 1. This is x sub 2, y sub 2, the second point. They'll have different x values and they'll have different y values potentially. So how do we figure out how long this side is, knowing just that information? Nope. Don't even copy this down. So here's your triangle. I just want you to look at it for now, because it's so much to keep track of, to write down and listen at the same time. How do we find out how long this side of the triangle is? Is it 5 units from here to here? This is 1, 2, 3, 4, 5. You know, here 1, 2, 3, 4, 5, 6, 7. It starts at 1 and it goes up to. So how long is it? It's 4. So if we used the distance between this point and we used the absolute value, how might you write that? from your homework. How do you write the distance just from here to here? It's 4. Where does the 4 come from? 5 minus 1. Could I say 1 minus 5?
Yeah.
Then I'd get a negative 4. So what do we do to the distance? Absolute value. Okay, excellent. So the absolute value of 5 minus 1 is equal to 4. So I'm just going to write the 4. We won't even say absolute value of 4 and then 4. We'll just say it's 4. You can do all that in your head. Okay, now, how far is it along this leg?
5.
Where does 5 come from?
7 minus 2.
7 minus 2. Or 2 minus 7, right? It doesn't matter. But if I did 7 minus 2, its absolute value is 5. Okay, so let's go back to the Pythagorean. If you know that this is 4 and that this is 5, how do we determine the hypotenuse length? So 4's got to be squared, 5's got to be squared, and then along here, let's call that D. D has to be squared. So if I took 4 squared and I added 5 squared, that number will be equal to whatever this length is squared. That's the Pythagorean. So this is 16, that's 25. What's 16 plus 25? 31. 41? So then we have to take the square root of this, the square root of this. So that distance is the square root of 41. So that's a little bit bigger than 6, smaller than 7. Okay, so let's work backwards. We had to square the 4. So we have to square what's in the absolute value. We have to add. And we have to square this number. And that's equal to the distance squared. What's your question?
Why do we have to do the square root?
Okay, why do we do the square root here? Because in the Pythagorean, this leg squared plus that leg squared is equal to that length squared. So this 4 squared plus 5 squared equals that length squared. So when I put all that together and I got 41, so this is 41 is equal to the distance squared. In order to know what D is, we take the square root of it. And then we take the square root of the 41 also. We have to take the square root of both sides of the equal sign.
You want to get D without an exponent, and that's how you get rid of the exponent.
Yeah.
Square it.
Yeah, if you have like the square root of some value, but it is, you could think of it this way. That's the square root of that number times that. And a square root is looking for the number which multiplied by itself equals what's in here. So what this just becomes 1 of these. So in essence, the square root and the squaring, they're inverse. They undo each other. Thanks. Yeah, if we're trying to figure out how many miles that is, yeah, we're going to round it off. We're not going to say the square root of 41. So yeah, makes sense. So that's probably what, 6.4? Okay? It's about equal to. Any other questions you'd like to ask?
Did you write that down?
No. I have more questions for you. See, this is not a real quick, short one, is it? This one drags out. Where does that 5, where did that come from?
The ending point is,
Up here, right?
yeah.
Okay, so that 5 is not that, is it? No, that's this. Where does the 1 come from?
The X, the
Yeah, it comes from this point's y value. But I want to ignore that point, because it's the same y value as this point. So this distance along, bad squeezing. This distance here is 5 minus 1's absolute value. Or 1 minus 5's absolute value. Doesn't matter which way we look. Where does the 7 come from?
the ending point, that one point, yeah.
Where does the 2 come from?
The,
So there we have 2 points. And we have enough information to figure out how far it is in between them, even though it's not a straight line. So we took the difference between the y values, absolute value, and squared it. That's the difference between how far up and down we are. And we took the difference across, which is this right here. We took that difference, which is a distance, and we squared it. We applied the Pythagorean, and we came up with how far it is from here to here. Yes?
Why would the 5 go in front of the 2?
The 5 would not go with the 2 because it does not represent a distance. You see, here, if I just look at this segment, this line, from here to here is from 5 down to 1. It's not from 5 down to 2. So we have to measure the length in this direction. And then we have to measure the length again in this direction in a straight line. So as we look across this side of the triangle, that's following the x-axis. And if we look at this side, it's following the y-axis.
So why 2 then?
What's that?
Why the 2?
Why the 2? Because the 2 represents, so to get to this point, it's 2 over and 5 up.
So we're just doing the points then, not the length?
We're using the points to determine the length. So for example, when I gave you a point and another point in your homework that had the same x value, there was 0 left-right distance. It was only a vertical distance. So you took whatever that number was, subtract this number, and found its absolute value. That gave you this distance. But as soon as we change it, and we go horizontally, then the y values, the vertical numbers, stay the same. So there's no vertical distance from this point to this point. So some of your homework questions had you doing, like the first one, it was, something, I can't remember what it was, we were like at -8, and it went from -10 to 7. Well, there was no change vertically. Excuse me, no, it's like, there was a change. That one, now, the first one was no change vertically. But if the, for example, if the y values stay the same, then the x values change, and that creates a horizontal change in distance. So I'm going to clean that up for you a little bit to write this down. This is the formula for anything on the coordinate plane, whether they align vertically, horizontally, or you have to do a diagonal. The distance between any two points is equal to, see, we had to take the square root of 41, right, to get d. So really, if we wanted to, we could skip that squared and just take the square root of all of that work.
Wait, can we write this down?
Yeah, so this one you can write down. So it is the square root of. Oops, I did it the way we are doing it, because algebra comes up with parentheses, right?
Yeah,
Yeah, I know, that's what's weird.
because I think it's if you have exponents, it's gonna square, it's gonna positive,
Yeah, it comes out positive anyway.
yeah.
So, yeah, but we're not doing that with
Yeah.
that just yet. That will come.
Sorry.
Oh, that's all right. First time I did it, I got all goofed up. So this is it right here. That's the distance formula. Let's give them sticky notes, sticky graph paper, okay? I'm gonna get a whole bunch more. And do you guys have any sticky graph paper?
Yeah,
Do you still have one?
we have
If
one.
you have one, then you just tell me.
Yeah, if you need one, we can give you more. But with this formula, I'd like you to put a picture of it on sticky graph paper. So who still needs some?
You wanna keep the same together.
Anybody else? Right there. New, I'm gonna walk you through one that's gonna be a little bit neater and cleaner looking picture, okay? It'll be a lot nicer looking picture. So, on your grid, or your graph paper, you can just draw this on the graph paper. You don't even need X and Y axes. I just want you to use your graph paper to make a triangle that's going to be big enough for you to label the vertices. Turn it into a right triangle by showing a box. And here's what we're going to do. We're just going to write x sub 1, comma, y sub 1. That's 1 point. And then x sub 2, y sub 2. That's the other point. It doesn't matter which is number 1 and which is number 2. It will not matter because when you subtract the numbers and take the absolute value, you're going to get the same value.
Can we write this on our graph paper?
Yeah, so put this on the graph paper. What I have right up here. Have your formula real close by. Okay, I'm going to do one. Line by line, boom, 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 boom. Not this one. with him when he gets done. They do the same thing on paper. Give the distance formula real close by. Okay, so I'm gonna give you 2 points, and I want you to go and use the distance formula as it's written here, line by line. I want you to show me your work to the best of your ability, finding the distance between these 2 points.
Put graph paper.
I'm sorry? Not using graph paper, not counting. You can do this on your paper, just underneath, wherever you have your distance formula written, so this is your work.
Don't need graph paper.
Nope. So those are the 2 points, 4, 7, and negative 6, 10. Yeah, this should be on the graph paper. And then I want this written just in your homework notebook, or next to the graph paper, or on the graph paper. Either one is fine. Keep them together. And then I'm going to get you started with this. So what I'd like you to do in your notes is I'd like you to write these 2 points as ordered pairs. Exactly what I have up on the board now. And I'm going to tell you to use this as point number 1, and this is point number 2. And in the future, you can do it either way. But this is what we're going to do for now, just to be a little more concrete in what to do with the numbers.
Don't forget to start the square root, and you have to square everything.
So now you have your formula.
And for you, it'll be absolute value, right?
So the first thing you do is you substitute the values from here and rewrite this formula. So you're going to write distance equals, and then all this is going to go underneath the square root symbol. Absolute value of the difference between the x's squared plus. So this is the absolute value. So we're going to take our 2 points. What is the number that we are calling x sub 2? Negative 6. Subtract the number we call our x, or our x sub 1? 4. That's going to get squared. But we're going to write it all in before we do any of the arithmetic. Put your y's in there, go to the next line, and begin solving line by line, step by step.
It doesn't matter if you have negative 6 minus 4 or 4 minus negative 6.
Yeah, it doesn't matter what this is, but I would suggest that you keep track because there's other things that we're going to use some of these patterns for. Keep track of x, one of these, subtract the other, and then go back and in the same order subtract to find the difference. There are things that are going to happen in the next few weeks. We don't want to just go willy-nilly and say, oh, just take the x's in any order and the y's in any order. When you begin with one point and you subtract the other, stay in that pattern. Yeah, so then 4 subtract negative 6 equals how much? Subtracting the negative, that's the same as adding. Okay, so now you're going to rewrite all of the symbols. Everything's going to get rewritten. or 109.
And then it's, that's,
That's great. Sometimes they let you go to the 100.
Why would this be still square root?
Everything is, this is the square root.
Yeah, but, and then this is square root, but this is taking out the square root.
No, it isn't. First of all, you haven't written in your square root on the first line. You need the radical symbol over everything. The square root symbol over the whole thing.
Yeah, you're good.
There you go. So now, you haven't gotten rid of that yet.
Yeah, yeah.
So you gotta put it over the 10 squared plus.
Square root, why would there still be the
These are squares. This is the square root. So you need to square each of those numbers, then add them. You need to follow the order of operations like that.
Well, you could have put the square
And
root.
rewrite underneath the
Where
square
we
root
still have
symbol.
the square root this number.
yeah,
So your square root symbol is a grouping symbol. You gotta do everything by order of operations underneath it. Okay, so there you go. So,
That's
so
pi.
you got the square root of,
it's 10 squared.
so the square root symbol. Yeah. Yeah.
Square root symbol is
So
pi.
do we, square it, what do we,
Yeah, that's what it is.
do the absolute numbers?
You do the absolute, you work inside the absolute value bars.
That's what it is.
Oh, okay, wait, that's.
Yeah. So you get a negative 10 squared, so negative 10. So negative 10 comes out as being that. And then that's 10 squared. Whoa.
Like, what is the, 10 by 4 from what?
Now my clock is slow.
I think that's just, really messed up with the coordinates.
Yeah, you know what? We're just, if you can get it all the way to the end, if you can try to do that, but we'll pick up on Monday and we'll look at it and we'll let you finish it out and talk you through it as well. So there's no additional homework other than if you can finish on just one problem, that would be sweet. Yeah.
10.44.
I'll take a picture.
Oh, yeah. Oh, yeah. Good. Put my hat back on.
You're welcome, Kate. Bye.